To analyze the differences between wiring systems at different distances from the roof, a compilation of all the wiring system 90th percentile temperature rises for the period of time each day where the solar irradiance was greater than or equal to 1,000 watts per square meter was made for each of the 4 elevations. The 90th percentile values were used to eliminate the maximum temperatures that were only being experienced for a very short period of time when the solar irradiance peaked for that day. Note, however, there were typically only a few degrees F or less difference between the 90th and 75th percentile values. This analysis is shown as a box plot. This is what you should know about a box plot. Outlier. An unusually large or small observation. Values beyond the whiskers are outliers. By default, the upper whisker extends to the highest data value within the upper limit. By default, the top of the box is the third quartile. 75% of the data values are less than or equal to this value. Median, the middle of the data. Half of the observations are less than or equal to it. By default, the bottom of the box is the first quartile. 25% of the data values are less than or equal to this value. By default, the lower whisker extends to the lowest value within the lower limit. Note, a crosshairs within a box also represents the mean or average of the data. This box plot shows the differences between the different individual wiring systems. Note that the MC and TC cables were black in color and the SC cable was light gray in color. This histogram shows the 90th percentile temperature rise data for wiring systems directly on the roof. Note, for all of the 17 test samples of wiring systems mounted directly on the roof, the mean or average temperature rise was 48.8 degrees F, with a standard deviation of 6.8 degrees F. Confidence intervals are often used as a statistical estimate to bracket data parameters with a known degree of certainty. A 95% confidence interval is suggested as an appropriate safety factor to represent the true population of the data from the sampled population. For this case, maximum temperature rise for all wiring systems mounted directly on the roof with a 95% confidence interval would be 62.2 degrees F. An observation from the initial box plot appears to show that there is little difference between mean temperature rises for test samples of wiring systems mounted 1/2, 3.5, and 12 inches above the roof. Neglecting any heat convection or re-radiation from the surface of the roof, this would be expected since the distance from the sun to the surface of the earth is large as compared to the distance between the 3 wiring systems. This was verified with a computer analysis of variance. It is expected that distances greater than 12 inches will also show this minimal variation. This histogram shows the 90th percentile temperature rise data for all wiring systems mounted 1/2, 3.5, and 12 inches above the roof. For all 51 test samples of wiring systems mounted off the roof, the mean temperature rise was 38.5 degrees F, with a standard deviation of 6.6 degrees F. The maximum temperature rise for all wiring systems mounted off the roof with a 95% confidence interval would be 51.4 degrees F.